Hello, and thank you for joining us for today's webinar, VRF for K-12 schools, saving energy costs and ensuring comfort. Sponsored by Mitsubishi Electric Trane HVAC US. My name is Joe Agron. I'm Editor-in-Chief of American School and University, and I'll be your moderator today. Before we begin, a few words about this webinar technology. This platform allows you to be more involved with the presentation and, more importantly, allows you to watch this event the way that you want to watch it. To begin, feel free to customize your webcast console. You can move windows around by dragging on the title bar or resize your windows by clicking on the lower right corner of any window. You will notice a toolbar at the bottom of your console. These buttons allow you to open and close widgets on your screen. If at any time you experience difficulties with the audio or advancing of the slides, simply press your F5 key to refresh your webinar console. We encourage you to ask questions at any time using the Q&A widget on the left side of your screen. We will address as many of your questions as possible at the end of the presentation. We appreciate your feedback, so please click on the survey icon and complete the form during the presentation. Now I'd like to introduce today's presenters. Brian Wright currently serves as the Director of Educational Sales for Mitsubishi Electric Trane HVAC US, helping school districts across the country select and integrate innovative and energy-efficient variable refrigerant flow technology into their educational facilities. With nearly 20 years' experience in the HVAC industry, Brian specializes in working with project teams on both new builds and renovations. Active in a number of education and facilities associations, Brian serves as a business partners representative for the Southeast region of APPA, MSAPPA, and the National School Plant Management Association. Mike Steger serves as a Director of Facilities Management for Berkeley Preparatory School. With over 32 years of experience overseeing K-12 and higher education facilities, Mike has a passion for sustainable buildings and operation. Throughout his career, he's decreased carbon footprint and increased cost savings by nearly $1 million through the optimization of mechanical equipment, strategic scheduling, and implementation of environmentally sustainable programs. Mike co-founded the Florida chapter of the Association of Physical Plant Administrators and currently serves as the president of the Southeast region of the Association of Physical Plant Administrators. With that, let's begin. Over to you, Brian.
Thank you, Joe. Before we get started today's discussion, we're going to overview the basics of VRF, or variable refrigerant flow, its technologies, its operation, and a little bit on how it can be applied. So what are VRF systems? Variable refrigerant flow, VRF, systems move conditioned refrigerant through small diameter piping to zones requiring heating and cooling. VRF systems only use a precise amount of energy to keep each interior zone at its desired temperature. VRF operation. So what this slide shows is a conventional HVAC system versus a VRF system. And it shows it off of set points, okay? So most conventional systems use a single stage compressor, while VRF has an inverter compressor, which allows the system to modulate energy. So think of a car's gas pedal on a conventional system. There's two positions. It's either all the way up or all the way down. Now that's not a very efficient way to operate a car, and it's definitely not an efficient way to operate an HVAC system. VRF allows you to modulate that gas pedal. So in this case, it's the compressor, using only the amount of energy that is required. This is not only extremely efficient, but it also allows for much greater comfort. So simultaneous heating and cooling. On the left-hand side on this slide, we have an outdoor unit or a condenser. In this case, it's an air-cooled condenser. In the center, we have a BC controller, which is also called a branch controller. And on the right-hand side, we have our indoor units. Now, this is showing 4 different styles of indoor units, but you can have all of the same or a mixture. It works the same. So education applications typically require simultaneous heating and cooling, being able to heat and cool at the same time in different classrooms. So think of a school gym versus a classroom. The school gym may need to be cooling, while the classroom may need to be heating. Schools with limited capacity in today's situation, like hybrid learning or virtual versus in-person, you may have some classrooms that don't have any kids in it and other classrooms that are full to capacity. Another way to look at this is you may have kids in one area doing jumping jacks that require AC, and other kids in another area that are taking a test or, that may need a little bit of heating. VRF has the ability to cool the classroom requiring AC and take that same heat to another classroom requiring heating without exhausting it out the condenser. So basically, we're moving energy from one side of the building to the other without exhausting it out of the building. So no other technology can do this. So equipment options. So we have a couple different condenser options on the left-hand side of this slide. The first one is an air-cooled condenser. The second one that overlays it is our water source VRF system. So depending on the location of your building, your efficiency goals, your existing equipment, and really important, your maintenance staff capabilities, you may choose to use air source over water source. So air source heats and cools refrigerant with air. Water source systems rely on chill water to regulate the refrigerant temperature. So for instance, if your staff is used to working on traditional or split systems, air source may be the solution for you. If your staff is used to working on geothermal systems or a chill water system, then a water source VRF system, it may be the way to go. So both systems provide optimal energy efficiency and comfort. Now, as for the indoor units, these are just a few examples of what we have, but we have indoor units that fit any style or aesthetic preference. Especially when developing a school, we understand having a range of equipment options is the key for owners, engineers, and architects. And again, these are just a few of our styles of systems that we have. Extreme climate performance. So contrary to outdated ideas, this is not your heat pump of the past. VRF heat pumps are able to provide heating in extreme cold conditions. Our VRF systems perform in conditions from -31 degrees all the way up to 115 degrees. So with our hyperheat technology, you can ensure that your students and your staff are comfortable year-round without auxiliary heating. This saves money and reduces CO2 emissions by switching from natural gas or oil. So who can benefit from VRF systems? So pretty much any project you have, if it's small, if it's large, if it's a retrofit, any type that you can think of would benefit from VRF. So here's a couple of examples. The first one on the top right-hand corner of the screen is Hollis Primary School in Hollis, New Hampshire. Now, this is a K-12 school that was built in the 50s. It was in desperate need of major energy retrofit upgrades. So the utility expenses were through the roof. The school was uncomfortable pretty much in every season. And the school board selected to go with VRF for its efficiency, operational cost, and a commitment to sustainable practices. The building on the bottom right-hand corner of the screen, this is Fairmont State University. It's a small public university in Fairmont, West Virginia. This was actually a new construction project. They needed to add a 3-story dormitory building to accommodate 345 students. While the VAV system was originally planned for this application, VRF proved to have a much better payback cycle. Now, while this is not a K-12 school, I wanted to show you the versatility of VRF and how it can be easily scaled to any size. If you have a 71-story building in New York or an IT room in Southern California and anything in between, VRF is a perfect solution for your application. So now we have some basic, a baseline knowledge of VRF technology. Let's dive into today's example of Berkeley Preparatory School. Mike is going to start by sharing some of the stats on the school and why HVAC upgrade was required. Mike, turn it over to you, brother.
Thank you, Brian. I appreciate that. Thank you, everyone, for the invitation to present. I always like to share a little bit about what we're doing down here in South Central Florida. So Berkeley Preparatory School, we're located in Tampa, Florida. We're approximately a mile as the crow flies from the north end of Tampa Bay, so we see all sorts of weather, humidity, etc. We're 1,380 students, pre-K through 12th grade, 84 acres, and 34 buildings with a skosh over 362,000 square feet. So as we got into VRF, we realized that, we had some challenges as far as, budget constraints and, needing to just meet the needs of various clientele throughout the school. So a couple of the things that we realized we needed to address, of course, high utility costs. Most of these through Tampa Electric Company, most of these accounts are on a demand rate. So offsetting peaks throughout the day is important to maintaining our long-term, or to keeping our long-term costs down. And ultimately, we found that VRF systems and good scheduling certainly help with that. Also, being in Florida in general, and then for us, so close to the Bay, humidity is always a concern as we design any new system. So finding systems that can efficiently and economically address dehumidification is very important. And we've done that with the METUS systems. So I'll tell a little story on when I was interviewing for this position back in the summer of 2013. In the lobby of our administration building, there was a large aerial photo of campus, and in between the various interviews, I started counting, being the facilities guy that I am, started counting the rooftop package units over there, and realized that we were well over 130 RTUs serving campus. So when it was my turn to interview with the business and finance director, I had already formulated a plan to pitch a chilled water system to him, stuff that I was familiar with at the time. And so as I shared that, the guesstimated costs and timelines, ultimately that project was nixed, but he loved the idea and basically challenged me at that very moment to drive on with finding additional savings wherever we could. So I knew we needed a more efficient solution as we had a number of renovations and new construction projects on the books. So after some quick research, really pointed me that VRF was the next best thing. Again, this was 8 years ago. I had barely even heard of that. Most of our early spaces that were being upgraded were classrooms with a smaller number of offices, so we were really focused on serving the classrooms. And again, the ability for VRF to heat and cool simultaneously is super important to us, because as Brian mentioned earlier, one class could be sitting there taking an important hour-long test, not moving hardly a muscle, and the other could next door could be doing aerobics. You just don't know what you're going to get on a campus like this. So, and then as we progressed later on, we just became more evident that as we renovated these spaces that the VRF absolutely met all of our heating and cooling needs. And yes, in Florida, we, contrary to what folks might believe, we do need some heating down here because all of our blood is pretty thin. So, and then ultimately, you know, as noted, VRF provides great heating and cooling simultaneously to spaces adjacent one another, and that absolutely made the difference for us. We knew that, you know, cranking on heat strips and air handlers and rooftop package units just sets that electrical meter spinning, and as I noted, I would have been charged upon my hire to help the school save some money. So ultimately, what we have, we were drawn initially to the Mitsubishi, the METUS product, because of the native control system. We were struggling a little bit with our controls package here on campus, and just, you know, from what we knew we could see remotely or on site, absolutely made all the difference to us. And then add the functionality. Obviously, these systems provide great functionality. So the more we learned about the efficiency and the ease of operation, the Mitsubishi line, again, just became evident for us. Brian, if you want to maybe give us a little bit of specifics about what we've got installed here, that'd be great.
Oh, absolutely, Mike. So our design team worked with Berkeley Preparatory's design team to come up with a solution to meet the school district, the architects, and the engineers' expectations. So Mike had said earlier about humidity. That was something that was big for him. You know, the teachers there wanted to have a little bit of control within their classrooms. They wanted a little tighter control. So we came up with a solution that required 11, this is all of his different projects, but 11 outdoor units, a couple of mini splits, 80 indoor units, and then humidity was a real problem for him. So our solution to fix his humidity problem was to incorporate all that with dedicated outside air machines that are called premises, and those are Mitsubishi outside air machines. And then, you know, our native Mitsubishi electric controls, and then we needed to be able to integrate that with an existing BACnet control system. So all of this, you know, was important to Berkeley Preparatory. So, you know, we came up with a solution to meet his expectations, and he's got over 130 tons of VRF and 6 tons of mini splits. So is that what you're looking for, Mike?
Absolutely. Thanks, Brian. I always have to recognize that I don't always fully understand what I know about certain systems, and even after 32-ish years in the business, HVAC falls into that range. So we'll talk a little bit now about the projects that we had done. So back in 2016, we had a technology center and classroom refit. Had originally been art classrooms, and we were changing that over. So that was our first foray into VRF. A smaller space and, you know, a good opportunity to get our feet wet there. And then in 2017, we moved into a much larger area, predominantly classrooms, only a few thousand, if that, square feet of administrative space. The rest was all classrooms. So, you know, we had an opportunity to be able to meet the need of all of our students, which are, of course, our primary customer. 2018, we rolled into a big renovation for classroom and administrative space. Mitsubishi throughout that area, and then a brand new construction project around 30,000 square feet which is our early childhood education center. So we got pre-K, K, and 1, first grade in that space, and VRF throughout. One thing I'll note that in new construction, obviously, even in retrofit, really, the cassettes take very little room, very little space in a room, and they don't necessarily, the way they are piped in, they don't necessarily create conflicts for other trades, which is always helpful in a renovation. And at the same time, they look good. So, we keep labor costs down in the installation, and architecturally, they look good, which keeping the architect folks happy for that. So we're going to talk a little bit specifically about our utility cost. So prior to, and even in the years prior to 2015, our annual electrical spend was, $545,000 plus each year. Again, hence the charge for me to help save some money. We were able to be aggressive in scheduling throughout campus, but we really attribute the installation of VRF through campus as helping bring those costs down. And ultimately, we've enjoyed very little budget creep as the years have gone by, and certainly our Director of Business and Finance have appreciated that. So I remain on their Christmas card list for that area. Over two of those main projects, we received about $15,000 in rebates back from Tampa Electric. Really important for us to be able to note that, a lot of utilities offer those programs. Brian, I think you've got some additional information on that as well.
Absolutely. Mike, I just want to add that METUS or Mitsubishi Electric Trane employees can definitely help with your utility rebate options in your region. So if there's federal, state, local rebates, we will definitely help you uncover those. So at the end, we're going to share some contact information. Please, if you have any questions about rebates in your area, just make sure you reach out to one of our staff, and we will help you uncover those opportunities.
Excellent. Thanks, Brian. I appreciate that follow-up there. So as we look at our streamlined operation, one of the great benefits of the Mitsubishi Electric Controls solutions have really allowed us to be able to address the individual heating and cooling needs of the various spaces on campus, and certainly using the same refrigerant system is fantastic for that. Again, you never want to set a meter spinning if you don't have to, and their controls package allows scheduling to be a breeze. Generally, we operate here at Berkeley 7 a.m. to 6 p.m. Monday through Friday. We've always got, like everybody else, we've got some Saturday and the occasional Sunday event, but again, scheduling for that is very simple. We operate at 73-degree set point during the day, and then at night we go to a 78-degree setback. Through our energy management system, we're able to bring up the system from anywhere, make set point or runtime changes, troubleshoot, much more. And then again, we talk about humidity being an issue for us here. We probably could have gone to a higher setback, but 78 degrees seems like a pretty good number. It's relatively comfortable if somebody comes in during the evening or on a weekend to work. And again, with the efficiency of the VRF, we don't really see any significant increases in costs due to keeping it there. Brian, you've got some information on third-party integration that I think will be helpful to this.
Yeah, so when it comes to third-party integration, the key to a successful integration is getting the manufacturer involved. So we have staff employees that can help you remotely or if it's called out in your specifications, we can actually come to the job site to help with the integration, to oversee it, to make sure things go correctly, especially with third-party integrators. They don't necessarily know all the manufacturers that are out there, and having the manufacturer on site to answer questions and to correct things in the field in the moment is the key to a successful integration.
Excellent. Good information there, Brian. So let's talk a little bit about maintenance. I think everybody, or at least a good majority of folks, are certainly interested in that. And as noted earlier, we've got 130 tons of Mitsubishi VRF on campus, including the 7 premises outside air units. And what we found is that our typical maintenance routine now is much more cost effective and more simpler than with traditional maintenance systems. So, we've gone from having to wash and maintain 43 condensing coils down to 5. We've gone from using gauges to diagnose refrigeration problems to using a diagnostic tool from METUS that can be hooked up anywhere basically on the MNet control network. So we can hook up to an indoor unit, an outdoor unit, a wall sensor, and get pretty much all the operating and troubleshooting information we need just in that one spot. And then ultimately there's not much more required for maintenance. You wash your coils, you maintain your drain lines, and you change some air filters. And ultimately they're easier to get to and, less of what we had before. Sorry about that. Couldn't get this to go. So, manufacturer support. Brian, you can probably talk us through this more than anybody.
Absolutely, Mike. So, METUS has a nationwide distribution support network. So, with almost 500 staff employees that are employed to support your projects. So from our service department servicing our distributor networks, their DSGs and DTSs, to our level 1 and level 2 support when you call in our support hotlines, supporting everything from new applications to old product literature. We have 6 business units across the country, each one of them having an on-staff engineer to support your engineers designing the project, or if you have some technical questions up front, they can help with that too. We also have area and regional employees in almost every major city in the nation. And then we also have a dedicated educational vertical market team that's, supports the entire country. Each one of these regional educational vertical market team leader, they only support the educational industry. And their primary purpose, and this is my team, is to drive resources to your projects. They've also developed with our training group a learning management system. We call it an LMS system. This is free for educational facilities. There's 3 learning tracks through this LMS system. There's starting courses for installation, there's project management courses, and there's service courses. So we have all different types of courses. If you're a maintenance director like you, Mike, and you want to learn a little bit about a VRF system before you do a job walk, project management course may be the way to go. If you have a service tech that's brand new, that's green, that doesn't know anything about VRF, we can take them from there and then work them towards becoming a quality service tech. If you have somebody that's got a little bit more skills, we have the courses for them also. So all of these learning management courses are all free for educational facilities, and we will share some of that information at the end and how to get signed up for those courses. So a few takeaways. So VRF uses only a precise amount of energy to keep each one of your interior zones at the desired temperature. An R2 system, when simultaneous heating and cooling, it moves the energy from one side of the building to the other without exhausting that energy out of the building. Okay, so you're not wasting the energy. If one's needing cooling and one's needing heating, you're just moving the energy from one room to the next. So it's incredibly efficient. VRF systems offer a variety of unit styles to meet your comfort needs of any educational facility in any location in the United States. It doesn't matter if it's a K-12, like just a small elementary school, or a very, very large high school. VRF is a perfect solution for you. VRF systems offer streamlined operation and maintenance, and VRF system operation promotes energy efficiency and cost savings, and very important, sustainable building practices. So I just want to stress that. And with that, Andy is going to moderate our questions. Andy, do you have any questions for us?
We have a whole bunch of questions. Brian, Mike, thank you so much. It looks like we've sparked quite a conversation here, so let's get right into it. So one topic that is of clear interest to the audience is, how do VRF systems handle ventilation requirements, which is certainly a very hot topic in schools at this moment. So when we talk about outdoor air, how do VRF systems address?
Okay, so depending on the location, of the school, so in Mike's case, we have a dedicated outside air machine that pre-treats the outside air before it takes it to the space. So it's a separate air conditioning system. In his case, it's called a premises, and that runs it through a coil, and depending on the temperature, it has hot gas reheat available, so it can warm the air back up to maintain a neutral temperature in the space in southern Florida. And that is one of the most humid climates in the country. In New Mexico, for instance, where it's a little drier, we may use an energy recovery system that is not a mechanical device. It doesn't have an evaporator coil, for instance, on it, but we're using energy recovery to handle the outside air. So in southern Florida, we have a dedicated outside air machine called a CFMR unit, and it's a VRF split system that has hot gas reheat, and it handles the outside air. But the theme here is that it depends on the climate, and we want to make sure that we apply the right product to fit the needs for the actual climate itself. Okay, hopefully that helps.
Makes a lot. Yeah, I think that makes a lot of sense. There said a lot of interest in that subject. Let's talk about outdoor air a little bit more. Is there a possibility? Actually, no, not outdoor air. Let's talk about air quality a little bit more. Is there a possibility of integrating CO2 monitoring and CO2 demand control? VRF systems?
Absolutely. Absolutely. So if you're doing demand control ventilation, where you want to modulate the amount of outside air that comes into the space, and that would be done with the control system on top of one of our outside air machines. So where you would have a baseline to be able to say, okay, I need a certain amount of CFM to come to the space, and then I'm going to modulate in between that to get it below a certain level. You do that with a CO2 sensor. So, and that's something that our engineers can work with you guys to make sure that, we're designing a system to meet your needs. So demand control, and we can definitely do that.
Let's move on from the air to controls. We received several questions about controls. So, for example, we talked a little bit about integrating with a building automation system, but what controls can be managed, and what types of equipment, third-party and other, can be managed with a VRF system, and how does it connect to a building automation system?
Let me clarify the question. Are we talking about using a third-party control system, or are we talking about using native Mitsubishi METUS controls?
Well, let's look at both. So this question specifically is, can the VRF units be run through a building automation system? And if so, what controls can be managed? So here we're talking about just the system that a school might already have.
Okay, so if you have a system, so what I would recommend, whoever answers that question, is we will get you a points list of everything that you can pull in. If you're, BACnet or lawn, we can share that points list as to what information you can either pull out or receive from a VRF system. But it's typically BACnet. Lawn isn't quite as prevalent in schools, but we can do both. So VRF has onboard controls that can operate your building. So if you were predominantly a VRF system, predominantly VRF in your school, then you wouldn't even necessarily have to have an energy management system on that school. Now, you can. It's a simple device that allows you to be able to take a BACnet signal. We take a BACnet signal, and we can send it out and receive it. And we can pretty much do whatever you want to do. But if you don't have an energy management system and you wanted to be able to control lights and fans and things like that, we can control all that through our native VRF control system. So it just depends on what you're trying to accomplish. So if you have a school that you have an existing energy management system, we can absolutely tie into that. If you don't want to have an energy management system, like a full-blown energy management system, but you still want to be able to control some other devices, we can help you with that. It's quite versatile, so it just depends on what you're trying to do. And I would want to look at your particular situation and then tell you what pieces and parts you need to be able to make that happen.
Let's move on to a return on investment. So there are a few questions that we see with regard to the first cost, the install cost of a VRF system, and then questions, how long does it take to see a return on that investment? Some people might be scared off by initial first cost. So what kind of return can they expect, and how long does it take to see that return?
Okay, that is a very good question, and it's asked quite a bit. Okay, so when you typically look at first cost and you're comparing just equipment to equipment, typically VRF is more expensive. But when you start taking things into consideration like wire size, because we're not using, typically we don't use backup heat. So you have a huge reduction in cost there. Okay, so then you start talking about there's, sizing, for instance. So you don't have, your ductwork is considerably smaller. So your attic space is considerably smaller. So architecturally, we're saving a ton of money by going with VRF. And then when you don't have as many rooftops on the roof or as much equipment on the roof, the structural does not have to be beefed up so much. So when you look at it holistically, VRF 99% of the time makes more sense on first cost when you look at everything, all of the trades. When you break it down and you're just looking at equipment, is not really an accurate way to look at it. But when you look at it holistically, VRF almost always makes more sense. So, and it has a lot to do with how much you're paying for electricity, construction costs, all of those things. But we can absolutely look at your individual project and talk to you about, payback and numbers and things like that.
Okay, great. I think that should answer those questions. No, but here's a related one, though. What is the typical life expectancy of a VRF compressor?
A VRF compressor. So typical life expectancy is around 15 to 20 years if it's installed right. So one of the things, when I say installed right, you're pulling a vacuum, you're purging with nitrogen when you're soldering, you're doing all the best practices to make sure that there's no contaminants in your Freon system. That's why we developed the project management training. We want to make sure that as many people out there know what to look for while they're doing job walks and they're watching these mechanical contractors install equipment. So, if you don't purge with nitrogen, for instance, soot builds up on the inside of the pipe because the pipe gets hot. As soon as you add Freon to that system, it tends to clean the refrigerant. And where it'll work most of the time, you won't actually know that you're taking 5 or 6 years with life off the back side of the compressor. It's like taking, your brand new car and pouring, dirty motor oil in it. It will work, but it will take life off the compressor. So if it's installed right and if it's maintained right, you should get 15 to 20 years out of a VRF system.
Great. There's a question with regard to cold climate performance. So we covered this a little bit during the presentation, but it's going on into a little bit more detail. How do VRF systems work in extreme cold? So, for example, in Minnesota, if you're below freezing for 4 to 5 months of the year, how can a VRF system provide comfort?
It's off. So we pull heat off of the compressor. The compressor actually produces heat. So your typical heat pump, when you get to about freezing, 32 degrees, it becomes difficult for it to operate. Okay, so how we get down to negative 31 degrees is how the system works. So that's the hyperheat, the beauty between the hyperheat technology. And so that would be one where I would like to talk to them offline and, explain to them, how the compressor actually works and how we're able to get heat from the compressor and take that into the building to be able to heat their building.
All right. Fantastic.
Okay.
Let's talk about air filters. So where do the air filters typically go? Are they in each room? Are they in a central location? Where are air filters in a VRF system? Where are they typically located?
Okay, so a couple different places. If it's a cassette or a wall unit or a ductless system, they're at the unit itself. Okay, so if it's a cassette, they come with the standard washable filter, but in a lot of cases you can use up to a MERV 13 on them. So if they're in a ducted unit, they come at the return side of the unit, but in a lot of cases, if you duct the returns, you can put them at the entrance of the filter grill, at the entrance of the return grill. You just want to be careful to make sure that you're filtering your outside air before it enters if your outside air goes to the return side of the unit, you want to make sure that you filter that. So you want to be careful there. So there's a couple locations.
All right. This next question describes a specific scenario, but then it goes to a general question. So let me just read it for you. My school district is in the process of remodeling a 45-year-old, 260,000 square foot high school. I'm leaning towards VRF. Our current systems are less than optimal at controlling humidity due to oversized systems. Are VRF systems more tolerant of being oversized or undersized? And there's another part of how do the units work with DOAS systems, but I think you've kind of covered that. But go ahead.
Okay. And the answer is absolutely. So a VRF system typically needs 50% connected to the condenser for it to operate. Okay, so on that branch controller that we showed in the beginning of the presentation, we usually leave, there's 16 ports that come off that branch controller, and we usually leave a couple of them open, and that's specifically in schools to be able to add or take away from a system if needed. Now, every one of our indoor units has a linear expansion valve on it. So it's like an electronic expansion valve on a system that opens or closes either a little bit or a whole bunch. So it follows the load around the building. So if you don't have much load, that LEV, linear expansion valve, backs off. And so you pretty much always have an active coil. And if you have an active coil, you're dehumidifying. So you want to be at or below dew point, and then you're pulling moisture out of the system. So the next thing is the outside air machines typically handle all of your latent load or the moisture inside the building, so that are coming in from external forces. You get a little bit of moisture or latent load off of people, but most of it is from the outside air. So you're handling that with an outside air machine that's designed to do it. So if the VRF system is handling the comfort, and the outside air machine is handling the moisture or your outside air load. And that's how we're able to maintain very, very tight temperature and humidity controls between the two. And we have a whole lot of different outside air machines, like I described before, depending on your location in your building. So I want to know more about it, but we can definitely help solve your problems.
All right, well, let's answer a question with regard to scheduling. So this person wants to know, is it recommended to run VRF 24/7 or on a schedule of 8 a.m. to 5 p.m.? Which is more efficient?
Well, okay, depends on, I guess, who you talk to. I personally like to, I don't like to see the building drop that much out of range. So if you are going to have night setbacks, which I'm okay with, just, have it a few degrees. There's not much different. Your savings comes from when you go unoccupied and you're turning your outside air machines off, because you're not introducing that moisture, that latent load back into the building. That's where the savings comes from, because the VRF systems, if you leave the temperature alone, your building tends to operate a little bit better. You're not going to notice a huge difference if it's 3 or 4 degrees, but if you take it up to 80 degrees or 85 degrees in South Florida, you're potentially going to have a problem. So, and the savings is going to be negligible, because the VRF system, it ramps the compressor speed down. The LEVs almost close off to where the coils are barely staying active because you have no load in the building. So the biggest saving is when the load leaves the building and your outside air machines turn off because you go unoccupied. Hopefully that helped.
Hope so too. Next question. Can you somehow have 2 VRF indoor units in one large classroom or a large space simultaneously answering to one thermostat?
Yes, you can. So you absolutely can. You want to make sure that you're going to have them coming off that same port, like I was saying before. They're going to be in the same mode. You're not going to want to, for instance, have a heat recovery, unit with 2 separate ports coming into the classroom and then fighting themselves. You want them both in heating or both in cooling, and you definitely can have them run off of one sensor. Here's one other thing that I didn't get too much into. Every one of our indoor units comes with a thermistor in the return, so you don't necessarily even have to have a sensor on the wall if you don't want to, because we're monitoring coil line temperature and return temperature, and that's what's determining where that LEV position is. So some schools give the teachers a little bit of leeway, and they want them 2 to 5 degrees. Some want them to see a value on the wall so they know, and in other situations, they don't have anything. So it just depends on what you're doing. Like if you're in a gymnasium, you probably don't necessarily want a sensor on the wall, because it may get hit by a basketball or something and get destroyed. So you just run it off the thermistor inside the return. But to answer your question, absolutely, you can do that.
All right, great. Okay, next question. Can you describe how VRF systems handle defrost?
Yes.
For the outdoor.
So,
yep.
The outdoor unit. So if the unit goes into defrost mode, we have a split coil. So you're always going to be providing heating when it's in defrost mode. That is unique, So, so either one coil will be in heating and one cooling is in cooling. So what you're doing, what's in defrost mode, and pretty much all heat pumps, is that you're reversing the direction of the refrigerant. So instead of to melt the ice on the condenser outside, so instead of you're in the evaporator coil on the inside removing heat, you're now adding heat from the space to the coil to the condensing coil outside. So it just reverses it. But we have a split coil, so it's able to always provide heat. So you don't actually get cold blow or cold air coming out of the register grill.
Okay. Perfect. Thank you. Next question. Can you just address how condensation is handled in classrooms?
Sure. All indoor units, I'm assuming they're talking about water coming off of the evaporator coil and the drain lines. So I'll answer it that way. So if you have a cassette, for instance, that is in the center of the room, it would have what's called a lift pump on it. That lift pump is not a typical pump like a condensate pump. It throws the water up, a couple of feet, and then it gravity drains either into the sewage somewhere or below a sink, or into another condensate pump that can pump it anywhere out of the building. If we're on the outside of the wall with a wall mount unit, you typically you could pump it somewhere if you needed to, or you just do a gravity drain. But it's real similar to a split system. So it would operate the same way as a traditional split, that water comes off the evaporator coil into a drain line, or into a drain pan that enters into a drain line, and then you remove the condensate waste to where it's appropriate.
Perfect. This next question concerns the difference between air source systems and water source systems, and specifically, how much of a difference is there in terms of efficiency?
Well, okay, so they're really similar on the evaporator coil side. On the condensing side, there are some differences. So on water source, you don't have to derate based on outdoor temperature. It's based on the water temperature entering on the condensing side. So think of your condensing coil or your outdoor coil. You're rejecting that heat through water. Okay, so now we don't care where that water comes from. If you have a geothermal system, for instance, and your water loop is through geothermal and you're rejecting the heat into the ground, that's fine. If you have a cooling tower, you're rejecting the heat that way, that's okay too. So it's just the evaporator coil to the box where the compressor is. That's the part that's on the refrigerant side of it, and they're both real similar in efficiency. It just depends on, so the efficiency isn't much of a difference. It's really the derating part of it that makes such a big difference. And so, like if you're up north, for instance, and you're using a boiler system, it works perfect. If you're on a big building in New York and you want to have it on a cooling tower with a loop, it works great. You don't have to derate your cooling based on the outdoor temperature, or cooling or heating.
Okay. This next question is a bit unusual for our overall topic, but maybe there's a school where this is applicable. Can VRF be used for indoor agriculture, where there might be high sensible loads, from to lighting and as well as latent loads, because of plant evapotranspiration?
Yes, I don't know the details on that, but we do have a solution for that. We do have somebody that is in charge of that particular vertical market, and I would probably need to reference them back. But we absolutely have a solution for it. So I would just say that would be an offline topic that we could talk about.
Okay, great. All right, so what about larger zones with high ceilings? What kind of indoor units would be appropriate in those kind of spaces?
Okay.
Or how would that be handled with VRF?
That was a really, really good question. So through our distributors, we have access to, any size unit out there. And, so for instance, if it was you had a Trane air handler, a very large air handler, we could use our expansion valve, our linear expansion valve, we call them LEV kits, and we can use our LEV kit with our condensers, and then you have a VRF system of any size. And that ties directly to what Mike was talking about, our MNET control system. So it works on our control system with our compressors and our coils and our LEVs and a third-party air handler. So if you go above 8 tons, for instance, and you need something much larger than that, then we would use a third-party air handler, and you can, and we do a lot of that. So that's how we handle larger areas.
All right. Here's another one. How can I compare the benefits and costs and lifetime costs and utility costs of a VRF system design as compared to other traditional systems for a given project?
Well, that's another good question. We have the area sales managers that I described that are in just about every major city in the United States. Would love to talk to you about that comparison. And there's things that we can do, like if you have a building, for instance, before you hire your architect or your engineer, we would like to come out and talk to you about your building and give you ideas on what you can do. And we can compare first cost, operational cost, energy cost, through some software that we have, especially with our distributor partners using Trace, or our white software that we use for doing energy comparison, and give you recommendations and show you real tangible numbers. So, and by the way, we don't charge for this service, especially for schools. So if you need somebody to come out and take a look at your building, or you're just interested in this at all because you're looking at a future, expansion, or maybe an elementary school or using this technology, we want to talk to you about it. Our engineers, we're not going to stamp a set of plans for you, but we're going to look at it and give you recommendations that make sense. And if it doesn't make sense for whatever reason, we're going to tell you that too. So, and I think our team and our staff from one end of the country to the other is really good at that.
Perfect. We have a bunch more, but I think that's all the time we have for questions. This has been utterly fantastic. I can tell from the engagement, people, you've really done a lot to spark interest, conversation, and you'll need to follow up definitely with a lot of these individuals and professionals.
Well,
thanks.
I definitely appreciate that. Oh, go ahead. I'm sorry.
Sorry about that. I'll jump in here as we get to the close. As a note, this webcast's on-demand version will be available on the American School and University website within the next 24 hours, and a link to the recording will be sent to each of you via email shortly. But before we sign off, I'd like to mirror the thanks to our presenters, as well as our sponsor, Mitsubishi Electric Trane HVAC US. I'd also like to thank you, our audience, for taking the time today and sharing it with us. Thanks again for attending, and hope you all have a great remainder of your day.
I got one more thing to say if we're still on. There's some on the slide that's showing we have a few additional METUS resources. You know, we will be sending these out to y'all. So if you you know, subscribe to our newsletter, there's new technology and new things that are coming out every single day. It's super exciting. There's too much to get into right now, but if you want some more case studies, we have a ton of case studies that you can go read about other schools across the country and other applications to where you can find out if this is a good solution for your building. MyLink Drive is amazing. I would write that down right now and give it to all your service techs. If you have an old 20-year-old mini split and you need a maintenance and operation manual, that's the place to get it. You want to read about new technology, that's absolutely the place to get it. We didn't talk about warranties, but if you're looking for a contractor that's gone through our training and our requirements to get our warranty, which is a 10-year compressor warranty and a 10-year parts warranty, there's some requirements for that. And this portal is a place to be able to go and get that, you know, that information on that contractor in your area. And then if you have questions about anything else, our area sales managers in your area can answer them. And we will be, you know, sending this information out with the contact information for each one of these regional and area sales managers and the educational sales managers that are directly responsible for your particular area. So just wanted to shoot that out, and thank you very much for attending.